You've probably turned a car around a corner without thinking twice about it. But have you ever wondered why the outside wheel doesn't drag or skid while you turn? If both rear wheels were locked together on a single solid rod, they'd be forced to spin at the exact same speed all the time. That works fine when you're driving straight. The problem starts the second you turn. When a car goes around a corner, the wheel on the outside of the turn has to travel a longer distance than the wheel on the inside. It's the same reason runners in the outer lanes of a track start ahead of the ones on the inside. If both wheels spin at the same speed, one of them has to slip, hop, or drag. That would wear out tires fast, stress the axle, and make handling terrible. More than 200 years ago, engineers solved this with a device that's still under almost every rear-wheel drive car today. It's called a differential, and this is how it works. What you're looking at is a complete rear differential axle assembly. The two long rods extending left and right are the axle shafts. Each one connects directly to a wheel. Their job is simple: take rotational power and deliver it to the tires. All the magic happens in the bulge at the center, often called the housing or the pumpkin. That's where the differential itself lives. Power from the engine doesn't come straight to the wheels. It travels down the length of the car through the propeller shaft, also called the drive shaft. That shaft spins into the back of this housing and ends in a small but very strong gear called the pinion gear. The pinion gear meshes with a much larger gear you can clearly see in the image. That big one is the ring gear or crown wheel. The pinion and ring gear do two critical things at once. First, they turn the direction of power by 90 degrees. The drive shaft is spinning front to back, but the wheels need to spin side to side. These gears redirect that energy. Second, they multiply torque. The small pinion turns the big ring gear, just like using a small front sprocket and big rear sprocket on a bicycle to make pedaling easier. You get less speed but a lot more twisting force, which is exactly what you need to move a heavy car from a stop. Now, bolted to the back of that ring gear is the entire differential case, and this is where the real problem solving happens. Inside the case, you'll usually find a set of small gears called spider gears or pinion mate gears. These spider gears are mounted on a pin so they can spin freely. They mesh with two larger side gears, and each side gear is splined directly to one of the axle shafts.